Hi, we'd like to present a breakfast drink challenge to you. Which do you think is the healthiest breakfast drink? Coffee, tea, cocoa, or an energy drink? There are many things to consider in determining what makes a breakfast drink healthy. We need to know the amount of fat, fiber, sugar, calories, mineral nutrients, sodium, cholesterol, protein, and of course, caffeine. Most food and beverages have a label with nutrient facts which are easy to check. But how do they figure out what to put on those labels? There are many methods available to make those determinations. We're going to show you a straightforward one to compare the amount of key mineral nutrients in breakfast drinks. Magnesium is important for our muscles, nerve transmission, and immune system health. Phosphorus is important for healthy bones and teeth, and it's part of the system that maintains our acid-base balance. Potassium is needed for proper fluid balance, nerve transmission, and our muscles. Calcium is also important for healthy bones and teeth. Additionally, it helps with our muscles, nerve functioning, blood clotting, blood pressure regulation, and in keeping our immune systems healthy. No wonder we hear so much about the importance of calcium in our diets. Iron helps carry oxygen in the body for energy metabolism. And zinc helps with our taste perception, wound healing, and immune system health. The method we are going to use to find out how much of these minerals are in a breakfast drink is X-ray fluorescence spectrometry. That may sound complicated the first time you hear about it, but it's straightforward, fast, and accurate technology used to find out which elements on the periodic table are in a given material. Before we explain how XRF works, let's take a quick look at the amount of these key nutrients in a couple of our breakfast drink samples using an XRF method. We presented this challenge to about 450 scientists at an international conference, and most of them wanted it to be coffee. So let's start there. To keep it simple and clean, we used ground coffee in a small XRF sample cup. We lift the lid for access to the sample chamber and place the cup, sample side down, onto the analyzer window. We close the lid and confirm we are using the food quality application. Then we press the start button. We've got this test set up for a quick 30-second measurement, because all we want to do for now is to compare the relative amounts of the minerals in our breakfast drinks. You can see the elements listed with their measured value in parts per million. There is an error column to show the variability of the measurement. Since in many ways this is a statistical measurement, if you measure for a longer period of time, the error will improve. This coffee sample has 361 parts per million of magnesium, 105 parts per million of phosphorus, 194 parts per million of potassium, 21 parts per million of calcium, 28 parts per million of iron, and 12 parts per million of zinc. Since most of the scientists thought the healthiest breakfast drink was probably tea, let's look at it next to compare. We need to take the coffee sample out first. You'll note that XRF technology is non-destructive. Nothing happened to the sample while we were testing it. Now we'll measure our tea sample. We place the sample cup, sample side down, onto the analyzer window in the sample chamber. We close the lid and confirm we are using the food quality application. Then we press the start button. Now we can look at the differences in the coffee and tea. It looks like tea has a bit more phosphorus, calcium, iron, and zinc, but coffee has about the same amount of magnesium and more potassium. That made the coffee drinking scientists quite happy about their choice. Before we measure the other drinks, let's take a look at how XRF works. We'll compare it to how we sense color. Most of us can see visible spectral colors, from red to violet. If we look at an electromagnetic radiation diagram, we can see that visible light photon energy ranges from about 1.65 to 3.10 eV. That means when the sun or other light source shines on a sample, we can detect photon energy signatures of color from about 1.65 to 3.1 eV. We use the mechanisms in our optical system and the processors in our brain to determine a color. For example, we determine that these corn plants are green because our brain knows that photon energy signatures from 2.25 to 2.34 eV are green. Let's think of the XRF analyzer window as an eye which looks at samples to detect X-ray photon energy. It can see X-ray energy signatures from about 1,000 to 40,000 eV. However, instead of seeing these photon energy signatures as colors, it detects them as elements on the periodic table. Like colors, signature energies of the elements on the periodic table are well defined. For example, bromine has a primary signature energy at 11.9 keV. An XRF can detect photon energy signatures of magnesium at 1.2 keV, phosphorus at 2 keV, potassium at 3.3 keV, calcium at 3.7 keV, iron at 6.4 keV, and zinc at 8.6 keV. When the X-ray tube shines on a sample, the XRF uses mechanisms in its optical system and its processors to detect the elements in the form of a spectrum. Each element it detects appears as a peak along the energy axis. The intensity or number of photon energy signals of each keV spectral curve it detects helps determine its concentration. The simplified answers appear on the results screen. Let's consider a corn crop experiment to better understand. Two different types of corn seed were planted and grew. When the sun shines, most humans detect fields with two different shades of green, from 2.25 to 2.34 eV. If we let the XRF shine an X-ray tube on samples taken from each cornfield, it detects more photon energy signals of aluminum, silicon, and calcium in the dark green field. It detects more phosphorus and potassium in the light green field. Both views detect significant variances from the two different seed types, but they see them from different perspectives. Let's get back to the breakfast drinks and test our cocoa sample. We need to take out the tea sample and put the cocoa sample on the analyzer window, sample side down. After we close the cover, we need to confirm that it's still set up for the food quality application before we press start. The cocoa has about the same amount of magnesium as tea, a little more phosphorus, but less potassium, calcium, iron, and zinc. The cocoa scientists who saw these results were skeptical. They said the answers had to be wrong because good dark chocolate clearly had more mineral nutrients than the others. We explained that we used an inexpensive generic milk chocolate mix instead of a high-quality product. Let's look at the energy drink. First, we need to take the cocoa sample out of the chamber. We choose the energy mix sample and place it on the analyzer window, sample side down. We need to close the cover and check to make sure that it's still on the food quality application. Then we press start. Let's compare. The energy mix sample clearly has much more magnesium, calcium, iron, and zinc than the other breakfast drinks. Most of the scientists were shocked that the energy mix had the most mineral nutrients of the four. But this mix is a specialty formulation sold at health food stores, not the quick shot cans and bottles you can find near the register at a gas station. It wasn't meant to be a trick, but it did generate some fun conversations. Most of the scientists were very surprised that such a small and relatively inexpensive portable XRF spectrometer was so fast and easy to use. There were many questions, but 4 were the most frequent. Question 1. Do you have to use crushed powders, or can you measure the drinks as liquids, beans, or leaves? The answer to that one is you can measure any of those sample forms provided you put them in a sample cup to place over the analyzer window. However, for best results, the sample should be homogeneous with a flat surface. So for liquids, that's straightforward. But for leaves and beans, they should be dried and crushed into very small particles and then packed tightly into the sample cup with a good flat surface for best results. Question number 2. Can you analyze more than 4 elements in one sample? The answer to that is yes. You can simultaneously measure almost all the elements on the periodic table, from magnesium to uranium, in one sample with this XRF. The data, which contains photon energy signal properties of all elements measured, is stored in the unit. It can be transferred easily via Wi-Fi or USB for further inspection. Question 3. Can you measure anything else with this portable XRF? The answer to that is yes. You can measure anything that you can fit into the analyzer chamber. You can perform qualitative analysis on any material using spectrometer mode or Bruker PC software and analyzing the spectral data. If you want to perform quantitative analysis, you need to have an application calibration in place which is suited to the samples you're measuring, such as the food quality one. This particular unit has multiple calibrations stored on it. Of course, you can purchase custom calibrations or create your own calibrations offline using your own reference materials and then load it onto the analyzer. Question number 4. What if my sample is too big for the analyzer? If the sample does not fit into the analyzer chamber, then you can use a handheld XRF analyzer to perform your analysis. It can measure directly on large objects such as piping or equipment in a factory. It can also be taken into a field and directly measure the soil where a given plant is grown. If you need to switch to sample cup analysis, all you need to do is get a desk or benchtop stand to set the analyzer up in a more convenient configuration. We recommend operating with a PC when handheld XRFs are set up in a stand for ease of use. We hope you enjoyed this challenge and the opportunity to learn a little bit about XRF spectrometry. It's quite obvious that defining a healthiest breakfast drink is an individual matter. There is no right or wrong answer. Nutrients important to one person may not be to another, and of course the other contents will influence one's decision. If you'd like more information about how XRF can work for your applications, a budgetary quote, or to schedule a demonstration, please contact our sales department. Thank you for your time and attention. We hope you enjoyed this video demonstration. Please take care and stay safe.